Classification of water pollution. Water pollution can be classified into four categories: physical, chemical, biological, and physiological pollution of water. Physical pollution of water brings about changes in water with regard to its color, odor, density, taste, turbidity, and thermal properties, to name a few. Color change is not harmful unless it is associated with a toxic chemical. It affects the penetration of sunlight, inhibiting plant and animal metabolism. Most of the wastes discharged into water systems, uh, the pronounced colors due to organic dyes and inorganic complexes. Even a micro quantity equivalent to 0.002 ppm of magenta in water imparts a distinct red coloration. Tannery wastes, when discharged into iron containing water streams, yields deep green or blue coloration because of the interaction of tannins with iron. Turbidity. Turbidity in water mainly arises from colloidal matter, fine suspended particles, and soil erosion. Greater the turbidity, stronger is the sewage, and the industrial effluent concentrations are the worst effects. Hence, the degree of turbidity of a water course can be taken as a measure of the intensity of pollution. However, non turbidity does not mean that water is unpolluted, because clear water may also be heavily contaminated with acids, alkalis, etc., which do not cause turbidity. Turbid water becomes unsuitable for industrial purposes and also for domestic use, because iron, manganese, nickel, cobalt, lead, antimony, bismuth, etc., present in this water causes stains on clothes, sinks, etc. Turbidity measurements are useful in the evaluation of the effects of pollution by wastewaters and follows the course of self purification of rivers and streams. Various coagulants like ferric chloride, ferric sulfate, and ferric alum can check turbidity of water. Taste. Unpleasant or musty taste and color are and odor are produced by industrial effluents containing iron, manganese, free chlorine, phenols, and aquatic actinomycete. For example, even a zero point 0.1 ppm of iron can produce an inky taste, while phenol produces a bitter taste at 7 ppm. Manganese, chlorophenols, petroleum products, detergents, pesticides, etc., produce characteristic tastes in water. The decomposed organic matter like algae, fungi, bacteria, and pathogens impart peculiar taste. However, these pollutants can be removed by conventional water purification techniques like chlorination, chemical precipitation using activated carbon. Odor. Odor pollution of water is caused both by chemical agents like hydrogen sulfide, free chlorine, ammonia, phenols, alcohols, esters, hydrocarbons, and biological agents like algae, fungi, microorganisms, etc. Lower the pH, higher will be the amounts of hydrogen sulfide produced, and greater will be the odor nuisance. Organic and inorganic compounds of nitrogen, sulfur, phosphorus, and putrefied organic matters present in sewage cause foul odor in polluted water. Microorganisms like algae, oscillatoria, and rivularia cause muddy odor, whereas Anabaena produces a strong grassy odor. Protozoa imparts fishy odor to water. Chemical pollution of water. The chemical pollution of water causes changes in acidity, alkalinity, or pH and dissolved oxygen. It may be caused by either by organic pollutants or inorganic pollutants or by both. The organic pollutants can be biodegradable or non-biodegradable. Biodegradable organic pollutants include proteins from domestic sewage. Non-biodegradable organic pollutants are those which persist in the aquatic system for a long time. For example, pesticides and insecticides. The use of these organic compounds in protecting agricultural products poses serious water pollution problems because these toxic chemicals ultimately find their way into the nearby watercourse. Biological pollution of water is caused by the excretory products of man, animals, and birds. The main pollutants belong to coliform group and certain subgroups, fecal streptococci, and miscellaneous organisms. Biological pollution is also brought about by bacteria, viruses, algae, diatoms like protozoa, rotifers, crustaceans, and plant toxins. Physiological pollution of water is caused by several chemical agents such as chlorine, sulfur dioxide, hydrogen sulfide, ketones, phenols, amines, mercaptans, and hydroxybenzenes.